So, how are people going with the first week? How did you find the things like the Unix Survival Guide? Did you find that helpful? Cool. I was just saying, how are people going with getting themselves adjusted to the environment that we've provided you and all of that? Yep. Actually, it's horses for courses. It's like I use other text editors when I'm working with other people. I find that Nano is next to pointless to learn. And the reason why is that you just won't, like, there's nothing which is used in Nano which is then reused in something else. It doesn't help build your skills towards anything else. Vim actually it's embedded in the evolution of Unix and all of that. And like for example, for example, search and replace in Vim is pretty close to the same thing used in SED, for example. But we are assessing you on what you submit, not what you happen to use to produce the not what you use to produce the code, but the code itself, right? So we will encourage you in a certain direction, or I will encourage you in a certain direction, but there is no compulsion. But you will gain benefits from following that guidance. Okay, and I'll just leave it there. If people want to and are keen to learn more about this stuff, I'm more than happy to help. The only issue is if you're using an environment I'm not familiar with and you ask me for help, I'm going to go, yeah, sorry, I'm not familiar with that. But there's plenty of online help, etc., for whatever environment you choose. Yeah. Okay. Yeah. Some environments have less help than others, but it's all good. You probably wouldn't find much out there on getting help with working in VMS for a course like this either. So, yeah. Anyway. Okay, so what I want to start off talking about is the idea of precedence and associativity. Do you know what precedence means in a programming language? Operator precedence. Which things are calculated first? Are you all familiar with, or have you come across BODMAS when you're like in high school math? It's mostly that. But it's not. There's different names. It's mostly that, but there are a few additional rules because we have a few additional operators. So I've provided you a URL here, which you can have a quick look at. And it's playing funny buggers with me, so just give me a moment. Okay, yeah. Come on. Alrighty. Okay, we can see in this window here, if I just make it a bit, make it a bit bigger, like so. Precedence is how high up in the table. Things which are higher up in this table here get calculated first. So brackets, square brackets, arrow and the dot tend to have higher precedence. Then under that you've got things like size of your increment operators, your plus plus, minus minus, the address of and dereference operators, which we'll actually cover next week, where I'm saving up all the stuff on pointers for next week, and then pointers will be a big thing from then on. I want you to get a bit oriented before we get there. So all of these, so from the top down, but really it's just BODMAS with a couple of extra rules. So if you know BODMAS, if you know, for example, that multiplication happens before addition, and so on, then really it's these top ones here that you really want to worry about. And in particular, the arrow and the dot is probably things which you may or may not have used before, although if you've done some Java, you've come across the dot. And then there's things like size of and so on. Okay. Any questions about that? No. Okay. So now we've got associativity. Now that's the direction that an operation happens in. Does the operation happen from left to right, or does it happen from right to left? Most operators you know of are left to right. So going back to that, to here, we see that, for example, the dot and the arrow are left to right. Plus plus and things like that are right to left. Most things are left to right, but the important exception here is assignment. Right? So down here in this little square down here, all of these are different kinds of assignment. An assignment operates going from right to left. Unlike pretty much all the other operators. Okay? And here's an example, actually, of right to left associativity here. You see this A equals, just here, we've got this A equals B equals C equals 0. Max, those operators are all shorthand for applying that operation and then doing assignment. Just like plus equals. They're all at the same level. They're all at the same level of precedence. Because the thing which dominates all of these is assignment. An assignment is one of the last things you do in an expression. Yeah? Yeah. Okay. It's all good. You should never be like basically if you're wondering about something, then somebody else is wondering about that too. So you're best off just asking. And yep, if that's a question everyone else knows the answer to, then that's okay, that's fine. But maybe you're the brave one and someone else is shy, and therefore you're going to be doing other people a favour by coming forward and asking a question. Okay, so we've got these increment operators. So x plus plus or plus plus x. Yep, I agree with that, Brad. But question is, what's the difference? What's the difference between x plus plus and plus plus x? Yeah. But there's something, actually, if you dig a bit deeper, what you realise, yeah, I think Brad's kind of onto it a bit there, in the sense that a post increment has to create a temporary copy. Right? So if we look at that, x equals m plus plus. Well, we take a copy of what m is right now, then we increment its value, but we assign to x the old value, which means we had to store that temporary somewhere. So that's the main difference, is that with post increment, you've got two copies of the value. You got the value before the increment and the value after the increment. With a pre-increment, there's only one copy. So we are C programmers. We care about performance. So if I care about performance, which one am I going to prefer? Yeah, I'm going to prefer pre-increment. If I have no reason to hold that copy, why create it? There's no reason. Okay, so in your assignments, you are required to compile your program using these flags. So you're going to use GCC. I'll actually allow people on the server to use Clang if they wish, because they pretty much Clang, which is spelled as in C lang. Yeah. And the reason is that they're both pretty much, well, Clang is a newer compiler. In fact, a lot of the people who are involved in the development of Clang are people who work with C++ at Google. So it's there's a very big crossover between Google bods and Clang bods, in fact. But other than this slide, I'm not really going to mention Clang again, because by and large they work mostly the same. You probably want to specify in your README whether you use Clang or GCC, because there might be slightly different warnings. And yeah, we've even got the option of using different versions of GCC on the server, but we'll get to that quite a bit later in the course, actually. Okay, so here we go. GCC minus ANSI minus CPTW all minus pedantic hello.c minus o hello. So what on earth does all that mean, and why should I care? Well, GCC compiling with the ANSI standard, that's what the minus ANSI means. So that's the 1989 C standard. WAL, show all warnings, although it's not exactly all warnings, but it is most of the ones you want to know about. In fact, there's a level above that called W extra, which you might want to actually use. That's completely optional, but I think it's better to have a stricter compiler is a good thing. Pedantic in this case means the C90 standard. That is the internationalized standard of C89. So, and if you leave out these flags, you will pay. There are programs which will immediately crash if you don't, because they haven't output their warnings, and some warnings will crash your program. So having those warnings switched on is important. I don't mind how you do that, but obviously this is a little bit of a barrier for people who have said, well, I'm going to compile my program on Windows. You go, well, do you know how to specify these options with your compiler? If you do, well, okay. But I suspect most of you don't, and you would spend a lot of time searching for those options. And that will put you at a disadvantage doing all that searching for stuff. Whereas we've given you stuff for the Unix environment because it's one spot where you can do all your stuff. Whereas I don't necessarily know, for example, where to find the option in code blocks or whatever your preferred IDE is. So that's all there is to that. And I might just quickly show you. Okay, I'll just go into. Well, the ANSI specifies the C89 standard, and that's the standard you are required to compile to. There are major differences between, say, C89 and C99. But C89, C90 is just a internationalized version of C89, so that's not such a big deal. It's more, well, all later versions of C are supersets of ANSI C. So if something will work in ANSI C, it'll work in any later version of C. So it's the most portable. And say, for example, the Linux kernel. The Linux kernel is mostly written in ANSI C. So it's the most widely used version of C. So that's why we teach it. No worries. Okay. Okay. Okay, so I've got a message up the top here that I've hash defined, which is hello world text. I just print it out. That's the end. That's my whole program. I could have put the text in here, but I wanted to show you the idea of a pre-processor directive, which is what that is up there. So GCC Okay, now the Unix philosophy is if you got nothing bad to say nothing. So if there's no output, it means it succeeded. And then I just run it by /, which means run the program which is in the current directory called hello. And that's our hello world program. So there's a lot of discussion about, well, what's this? Isn't main the first program which runs, or the first function which runs when you Okay, that's a good point, Mark. Just let me have a quick look at that. Okay, what I'll do yeah, that's the issue. So what I'll do yeah, okay. Find dot executable. Okay, yep. What I'm going to do is, so currently all the files in here will be executable by you because I've now made all the executable files runnable by you. So I'll do that for the whole lot later, but at least you've got them there. But obviously if you want to edit them, you'll have to copy them into your own space and then, yeah. Okay. And don't worry, the code which you just saw me type there, you don't need to know for this course. I teach Unix courses and all kinds of stuff, so yeah. Okay, now, but the issue is here, right, that you'll often hear people say that main is the first function which is run in a C program, which is not exactly true. The truth is that the system provides a function which does various setup and that kind of stuff, and it calls main. I'm not such a Python person, but I suspect so. Yeah, so what that means, of course, is that if you return from main, or if you type exit bracket some integer, they are exactly the same, because there is a line in start which says return, which says exit brackets main. So it actually passes the return value from main into the exit function. So there's no difference. Does that make sense? So it means that, for example, in my program here, I could do return exit success or exit success, and from main it would make no difference. From another function it makes a difference, but from main, because main returns back to start, calling exit like this has meant the program, the actual machine code is the same. Okay? Yes, that's correct. It's provided by standard lib. There's quite a few things provided by standard lib, and we'll get onto those things in just a moment. But yeah. Yep. I find there are 3 header files that I include pretty much everywhere, which is standard IO, standard lib, and string. Yep. And that's something worth talking about. What do you think about the idea of returning 0 instead of exit success? Which do you think is preferable? It's not just readability. It is the question, it is a magic number. But portability is the issue. Because, for example, I was talking about a little bit earlier about VMS, which is an ancient operating system. It was back in the mid-90s, it was kind of a bit more popular with businesses. But it actually defined exit success to be 1 and failure to be 0. Which meant the portable way to actually return an exit status to the operating system was to use the defined constants, the constants which are specified by the standard. And we will be getting you to write portable C, portable anti-C. That's what you're writing. And the beauty of that is you can take that in any direction you like, but it's a starting point. If you decide you want to make, say, games on Windows, well, then you may explore the Windows API. Or if you're going to explore things on Linux, you might later on explore Linux API. But I will be expecting you from the start to create separate modules. That is a .c and .h pair. And each one is essentially handles similar responsibilities to what a class would in, say, Java or Python or something like that. I tend to use a lot of kind of object-oriented techniques, even though C is not technically an object-oriented language, but we should learn from history and what ways to make our lives easier and so on. Okay. Oh, I need to hurry up. Um, so, data structures. So, most of these you'll have come across from previous studies. So, integral types. So, they're whole numbers. Floating point types for fractional numbers. Enumerated types. You may not have come across these before, but these are cool. I think that this is one of the best things in the C language, and it's a real shame that they're not used more often, I think. And so it's basically a set of values which are related in some way, and they do have an underlying value. So in C, enumerated types are basically ints, so they're integers which are related in some way. So we'll get into them a little bit more. And then we've got bundled types. So these are kind of like an object. You know, so in, say, Python or Java or whatever you've used before, you will have had objects or classes where you could actually bundle things together into a single type. Now, C has the idea of structs. They're not quite classes. We've got to put a little bit of wrapping code around them and so on. But essentially, they fulfill a similar role for us. And then we've got collections. We're going to start off with arrays. And in the second assignment, we will be looking at linked lists. So they're the two collections we're going to look at in this course. So integral types are integers, yeah, whole numbers. Now, there is things like int, float, char, short, and so on. And these have sizes, but those sizes might vary on different systems. So, for example, on a 32-bit version of Windows, an int might be 4 bytes, but so might a long. On a 64-bit operating system, like, for example, the core teaching machines or Windows 10 or Mac OS 10, they will be, longs will be 8 bytes. And on earlier systems, an int might have been 16. So, might have been 2 bytes on an earlier system, like an earlier DOS, say. Ints might have been 16 bits instead of 32 bits. So, you got to be aware of how that change in size might impact upon things. In later versions of C, in C99, they specified some ints of specific size, but we don't have them yet. We don't have them in ANSI, so we're not going to go into them. So for this course, I'm not worried. I'm not worried about legacy systems too much, but that would depend upon what you're developing and if you care about it. As it is, we've got a fair amount of portability because we're using ANSI C, which is the most common form of C. It's like earlier forms like KNR, Kernighan and Ritchie C aren't really used very much. You might find some rare source code examples out there. I wouldn't worry too much about that. But yeah, the big issue might be is if you're trying to develop code which is supposed to run, say for example, on really old machines, then you might actually want to narrow the types that you use, or write code in such a way that it doesn't assume anything about size. That's better, actually. Every system provides there are constants provided, like int min and int max, so you don't even need to know how big an int is because those constants are there, and just compare to those, and if a value is outside of that range, it's not a valid int, for example. Yeah. Okay, so we have char. Now, people seem to think that a char means a character. Well, that's what we happen to have used it for. But it's also an integral. It's an 8-bit integer typically. Unless the bytes are parity bytes and then the 9 bits, but we won't worry about that. So we have int, unsigned int, long. So that they're the main integral types, right? I would these days probably prefer int above unsigned int because it generates faster code. There is a reason for that, which you can Google if you like, but it's just because of rules of unsigned integers, there's more code generated when you use them. So use an int over an unsigned int. And same for a long versus an unsigned long. Unless you just simply need that extra bit. If that extra bit really does matter to you. Like for example, a signed integer, there are 31 bits for the value and 1 bit for the sign. So that means we can have a value up to 2 to the power of 31 minus 1. Because there are 31 spots where you can have a 1 or a 0. Right? And that ends up being a number around 2 billion. Now, if that's not big enough for you, considering a long is 8 bytes, that means that that's 2 to the power of 63 minus 1, and the last bit's reserved for the sign. And if you use a calculator, you'll see just how big that is. In fact, why don't I do that? Okay. 2 to the power of 63. So that's 9 and 18 zeros after the 9. So a big number. Probably don't need anything bigger than that. And you see that even if we use 1 bit, right, if we took back that 1 bit, then we're going to be looking at 2 to the power of 64. It's not much bigger. So, yeah. Okay. Floating point numbers. So these are fractional numbers. What you have to be aware of is that they lack accuracy. So we can get a much broader range of numbers than we can with an integral type. But because what we do is basically we round to the closest bit, essentially. There are a lot of numbers we can't get an accurate representation for. Think about it this way. There is no way to represent 1/10 in floating point accurately. 1/10. Because if you do the math, it ends up that 1/10 is a recurring fraction. You know, like 1/3 is a recurring fraction in decimal. Well, yeah, 1/10 is a recurring fraction in base 2 floating point numbers. What did you use to get that? When rounded, sure. But you see that too, right? It means that actually those ones are just going to continue on. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That's not. That's yeah. So generally, if you're going to use money, use a pair of ints rather than a floating point number. It's just not accurate enough for, like, I don't want to lose a cent here or there. Yeah. I don't want to lose a cent here or there because of rounding. Yeah. Yeah, it's not going to go so well. Okay. So, one of the types that we've got is the enumeration. So an enumeration, as we can see here, in fact, yeah. There's even talk about things like a Tobin tax, which is essentially that. You know, like each transaction is charged a couple of cents. And so the only people really impacted upon that are people making lots and lots of currency exchanges. Anyway. So banks in particular are going to care about their accuracy. Okay, so let's have a look at this enum I've got here. In fact, this enum I provided you in the assignment 1 startup code. Has anyone seen that yet? So this is basically a Boolean, right? Which means, because C provides no Boolean type, but I have an enumeration here. And the way counting works on computers is we start counting from 0, right? So 0, 1. And I've got a little bit of discussion in the assignment spec about that. But that's an enumeration. Enumerations are like this. So here we have another one. We have days. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Days of the week. Or I could have months. And you see that more than one value, more than one symbol can have the same value. Right? And just very quickly, I'll show you an example. Oh yeah, enum's a string. So I've got this enumeration up here, right? And in fact, let's do this even a little bit more interesting. We'll go enum options. So now enum options opt equals 3. Right? It's so I've got here an enumeration which is just 0, 1, 2, 3, 4. And then what I do is I've also got a string, which is those same options, right? So 3, can anyone tell me what option 3 will select? Correct, Bradley, fantastic. 4th. Because it goes 0, 0, 1, 2, 3, 4. Correct. So rightio. And another benefit we get just having a look at a switch statement. If I leave out a switch statement, for example, up here I've got first, second, third, fourth, fifth, and then I have in fact this is a very wasteful switch statement. Yes, they're very much preferred, although in this case probably not so much, because I could just, considering I'm just printing out the int, I could just simply, and I want you to think about this, how printf how those two are the same. How that one line does the same thing as the entire switch statement. Not sure about that, but definitely it's less typing than a whole bunch of if statements. Although they're only supported for numeric types. So they're only supported for ints, for integer types. So ints, chars, enumerations, and so on. But this program will give me a compiler warning. Can anyone tell me why? You're just new to things, so it's okay if you don't know why. No. You don't have to have a default. Correct. Oh, there's a variable. Yeah. Now the issue is in fact that I haven't handled all of the. I've used opt because I've said, based on what opt is, do one of these things. The key issue is that there is no, I don't handle fifth. And, well, that's okay because it has nowhere to break through. Like it falls through to nowhere. Breaks are not required. There, in fact, are If, for example, yeah, I could, in fact, why don't I do that? So if I have, okay, oh, no, I'll come back. Okay, so what's gone wrong there? I compiled the wrong program. That's what's gone wrong there. So yeah, but let me show you something in regards to that. So case fifth. By the way, this is not something I want to see in your programs where I've got, by writing these numbers in directly here, what's the problem with that? Like, you know how I've got 1 written here and 2 written here and 3 and so on? What's the problem with me doing that? No, there's... Yeah. So they're not maintainable. This would be a nightmare to maintain. I should be using variables. Having said that, I'm just trying to show you how to the idea of a switch statement. Yeah. So what happens when you write code in a lecture? Notice, now there's no warnings. So using an enumeration for your switch actually does some of the validation work for you. Well, you'll declare most of your variables locally. So you, so I don't want you to be using global variables. So by declaring them in the function, they're essentially grouped in terms of purpose there anyway. No. Whatever works for you. In fact, you may even choose to use something like tmux, where you can have both windows in the one terminal. It's up to you. Whatever way of working, tmux. And I can actually divide up this screen and all this kind of stuff. So you can actually have multiple windows in the one window. But it's, look, whichever way is going to be more comfortable for you for working. Okay. So now let's get back to our slides here. And oh, did you notice that actually my one line of code did the same thing as the entire switch statement in this case? Right, this one line of code here did the same job as all of this. So it's probably more write code economically. But other than that, yeah. Switch statements are by far superior to having a whole sequence of ifs, elses, and ifs and elses, and so on and so forth, if what you're testing is an integer. But if you're not testing an integer, then you can't use switch. So okay. So a struct is kind of like an object in other languages, in the sense that we can put things together. So for example, here for date, I've got a day, a month, and a year all bundled together in this date structure. Likewise, here I have a definition for a student. And you see, I have a struct inside my struct. And that's fine. We can build things up on top of each other as much as we want. That's the simplicity of C, as we start off with very simple structures, and then we can build them up to whatever we want to build them up to. So that's that. Okay. And let's just see if I've got an example here. Don't seem to have any immediately on hand. Oh, I've got this academic results program. This is the last example you're going to see in a lecture with me where I use scanf, because as of next week we're going to be using fgetS, which is the correct thing to do. But let's see, is this... Yeah, no, it doesn't use a struct. Okay. Let's see if it's in week 3. Okay, perhaps not. I'll bring up another example. I have to keep moving. Okay, now unions. Unions we're probably not going to see much of. In fact, we won't see much of at all in this course. But I just thought I'd alert you to what they are. A union looks like a struct, yeah? In the sense that we've got these three values, just like we do in a struct. Difference with a union is only one of these can be initialized, or only one of these should be initialized. And the total space for the union is the space for the largest variable. So what this means is that this value here should be an int or a float or a double, but it can't be two at the same time. And then I've got this enumeration which specifies int, float and double. And then I put all of this into a struct. So now I've got the union and the enum. So according to whatever value is set in the enum, I know which value in the union has been set. So if VT says integer, then I know that I can get a value from I. If VT says float, I know I can get a value from F, and so on. They're not used quite as commonly these days because they're essentially a memory saving thing. But you can kind of get some kind of adaptable behavior to your variables. So, okay, it'll be one of these if it's set. That's kind of the idea. But we won't be covering any more about them, and we won't even have them on the exam. But I think that they are a useful thing for you to know about if you're going to do more C later on. Okay, now essentially all C functions are a single statement, but that statement is a group of many other statements. And so stuff in a block that is surrounded by braces, and braces being these fellas here. Oh, is it frozen? Can you all is just my screen is frozen? Okay, because my current version is frozen on the terminal. Okay. Alright. Oh no, it's just me. Never mind. Sorry about that. Okay. So, yeah, it's basically a grouping of statements within braces is called a block. Right? Now, a block is also the scope for any variables. So if you declare a variable inside a block, it is only going to be available inside that block, local variable. And you should declare all your variables at the beginning of a block. That's the rules in ANSI C. So if you think about going back to here, and if we go to okay, so this here is a block, yeah, but so is the entire thing. But I must declare, say I had, okay, I'm now going to get a compiler warning. Why am I going to get a compiler warning? No, that's fine. No. I have... Okay, let's just see the compiler warning and then... Yeah, Matthew's got it. And let's just... ISO C90 forbids mixed declarations and code. So it is simply the fact that that function call was before my declarations. Declarations need to be at the beginning of a block. And it has to do with memory allocation. Because in truth, all variables get allocated at the beginning of the block in which they are declared, even if they're not declared at the start of that block. That's just the way it's done. And that fixed it. That's good. So, if statements, yeah, should be no big deal there. Everyone should be pretty comfortable with them. If some expression, do. I guess the one thing to realize is that all expressions can be evaluated as a Boolean, including an assignment. The only things which can't be evaluated as Booleans are structs. Because a struct has what's called a scalar value. So it can't be considered, can't be automatically converted to a Boolean. But anything else can. Even pointers, strings, whatever. But we'll see how that works a little bit later. Generally speaking, I prefer for the both of these do action sequences to be a block, because it's a lot neater than having it all than single line statements. It's a lot harder to read, I think. Okay, so here we've got a few if statements. If x equals 3, so is x equivalent to 3, same as 3. Then we have Oh, look at that second one. What's that mean? Will that be true? Is that ever going to be true? This one here, if x equals 0, so it's an assignment, but an assignment returns a value to its environment, just like any other statement does. And the value returned is the value assigned. So the number 0, is that true or false? False, right? Therefore, the stuff in braces here will never be executed. What about this next one, if x? So, yeah, like what values would it evaluate to true or false for? Correct. So it's basically, it converts it to an int and tests, is it a 0 or a non-zero value? Well, it's a variable, and therefore it must exist in memory, because that's what a variable is. It's just a location. But yeah, it's basically it gets converted to an int. Yeah. Yeah. What about these last two? They're kind of interesting. If x equals get value is not equal to -1. I guess I want to compare that with the last one. Yeah. So it assigns x. In both cases, it assigns x and then tests it. It assigns to x and then tests it. This is a common idiom. It's all good. So this is a common idiom. I personally prefer the second style. I just find it's more readable. And it's likely to produce fewer compiler warnings than the first one. Anyway. Now the issue with the first one is if I remove this outer set of brackets, do we have a problem? It's not so much that, it's the fact that the compiler finds it ambiguous. So are you assigning or are you comparing? You try and do them both with this get value thing. So basically this says evaluate this and then compare that to this -1. Which the second one I think is clearer using the comma. And yes, the comma operator is do this then that and then return the result from the rightmost section. Yeah. So that's I use that all the time. I really like that. Anyway. That's my style. And then switch statements, which we saw a little bit before. So it can handle many different alternate values for an integral, that is an integer-based variable. Yep. And we can have a case label fall through, and I'll show you that. Okay. Yeah, we've basically got where fourth and fifth fall through and get the same value for both. Yeah. And while loops and do while loops. So let's very quickly have a look at them. So this is actually a function which I'm going to provide, that I've provided for you for your assignment. It's actually not quite correct. And in fact, what I would do is change this to make it a little bit easier. So basically we're going to read a character one at a time until we get a new line or a EOF. We're just going to print them out. So that just reads the character from the keyboard until we've reached a new line, or Control D, which is the EOF. So that's the idea of a while loop. So we have some condition. In this case, we're doing some work. So we get a character from the keyboard, then we do our comparison. And how many times does this loop run? Or how many... will it run at least once? Or maybe not at all? Correct. For example, so in essence that put char bit, yeah, Richard's correct. So if I show you actually, radio. In that case, you may not have noticed, but actually when I pressed enter the second time, it actually did output the enter key, but nothing else. So it actually printed out. And you notice that it actually buffers them. It doesn't do them one at a time. So it reads in that whole line and then processes that whole line. That's different to a do while, where for example, what I have here right now is an infinite loop, because 1 will never be 0. But This is a way you can actually comment out code. And you can nest it unlike comments. So, alrighty. So this will run until A is 50. So, yeah. It will definitely run at least once. So even if I said, oh yeah, if I said this, well, 1's never going to be 0, right? So okay, I've made a mistake here. Let's do so yeah. And okay. We can have for loops, which are pretty standard, like you've seen in Java. There is no kind of for each loop, but there is a for loop. And that's kind of an infinite loop we've got there. We initialize I to be 5, and we say while I is 5, but there's no change to it. Although typically we would do something like I equals 0, I is less than or equal to 5, plus I, and it will run 5 times, 6 times actually, because of the less than or equal to. Let's make it less than. But that should all be stuff you've come across before. I'm going to end tonight on some controversy, because I like controversy. And it's about something you may have been told in your previous programming courses, and that I do care about, but I don't think that dogma is necessarily the most useful thing when you're writing real software. And that is that you've been told that things like go-tos are harmful and evil and all of that, and don't ever use them. But the truth is that when you compile your program, it compiles into a series of go-tos. And so we have a sequence of instructions, we have a branching, which is essentially a go-to, jumping to somewhere else in memory, and so on. But most of the time, if you use a go-to, it kind of suggests that you really need to rethink what you're doing, because there are structured features of the language which can help you. That's true unless you're trying to write high performance software. For example, you're writing software in, say, the embedded space. You may in fact yeah, I don't think that's necessarily a good idea. I feel that go-tos should be used for performance only, because yeah, well, I have no problem with using break or continue. Actually, I use them all the time, and I would defy people who follow those rule books to show how that makes me a poorer programmer. I don't believe it does. But I would say that let's just say, for example, you're part of a team writing a new operating system. Every instruction takes time to run. So the choices you make there are going to be different to a piece of desktop software, because you're going to need that speed. Same for games, yeah. So I believe in using good structured programming standards and all that kind of stuff, but I also see that in the real world sometimes we have to break those rules. And I think that's something to think about. We won't, unfortunately, there's not really much opportunity in this course to do that. But I think that moving forward as a programmer is something that you want to be thinking about. Is that some rules, there are times when it's legitimate to break them. And I've provided two references here. One which is a debate on Stack Overflow, and one which is the original go-to considered harmful. Document. And you should make up your own mind. Having said that, I will penalise for go-tos in the assignments in this course because they're not performance critical applications. Okay, so finished that pretty much right on time. Any questions? Okay, I'll quickly show you that. I believe that was in Switch2.c. No. Oh, it doesn't really matter. I can do it here. The key thing is, if I say, for example, I've got this int ch up here, right? If I up here have a function call, right? And I'll define this function up here. It doesn't do anything. That's okay. Functions don't have to do anything. Right? Now, this program is valid, but I'm going to get a compiler warning because I don't have the variables all declared at the beginning of the block. So, in this example, I get this warning. Yeah. Whereas if I did this, no warning. Yeah. So simply, you have to have all your variables declared before any other code in each block. No worries. Okay. Any further questions or comments or whatever? Yeah, sure. If you've read over the material by the time that we're discussing it and you've thought a little bit about it, that's enough. Yeah. Yeah, because when I compile it resets the permissions. So I'll just, what I'll do, find here, type is a file, executable, exec ch mod 755. That should have fixed it.